Hello everyone, welcome to Math 100, section R.1. Today we're going to be spending our time talking about some review topics before we dive into our first chapter of the book. So, fractions. What are fractions? Fractions are division values that do not divide evenly. Fractions are division values that do not divide evenly. An example, 4/7. That does not divide evenly, right? That's a fraction. Another example could be 11/5. That does not divide evenly. That is a fraction. So, what about numerator and denominator? The numerator is the top number in a fraction. And I wrote this down here because the denominator is the bottom number in a fraction, right? Top and bottom. Numerator on top, denominator on bottom. So, we've got fractions, right? Each of us should know what fractions are, right? We should be comfortable with fractions, but we'll be doing a little bit of review to make sure we know each step and are clear on those rules. So first, we're going to talk about a technique, writing a fraction in lowest terms. So the first step is determine if the numerator and denominator share any divisors. If yes to part 1, divide both the numerator and denominator by the divisor you found. If they do share a divisor, we divide it out. Step 3, we repeat until the numerator and denominator share no common factors. They share no common divisors. They can't be reduced any further. So we're going to write each of the following fractions in lowest terms. 5/15. So 5/15. Do they share any divisors? Well, when I look at those, I see that 5 divides both of those. I can divide the top by 5 and the bottom by 5. Usually we write little divided by 5s next to it so you can remember what we're doing. And that is going to give me 5 divided by 5 is 1, and 15 divided by 5 is 3. So 5/15 is the same as 1/3. So we reduced it. How about the next one? 30/45. Do those share any divisors? Well, you might be tempted to say 5, and you'd be right, they do share a divisor of 5. But is there a bigger one? It'll save us time if we always divide by the biggest one. So let's take a look, and let's say you see 15 also divides 30 and 45. 15 winds up being the largest number that can divide both 30 and 45. 30 divided by 15 is 2. 45 divided by 15 is 3. So that reduces to 2/3. Now, in the last example, 150/200, maybe we don't see the largest number that divides it. 50 does divide both of those numbers and would be the largest number. But maybe you don't notice that right away. But maybe you notice that 10 divides both. They both end in 0, right? They're both divisible by 10. So I'm going to divide both by 10. 150 divided by 10 gives me 15. 200 divided by 10 gives me 20. I'm not done though. These still share. Repeat until they share no common factors. These still share a factor. They share 5 as a common factor or divisor, right? 5 divides both of those numbers. Well, 15 divided by 5 is 3, and 20 divided by 5 is 4. And now I'm done. Those share no divisors. Notice it took me 2 steps, but I still reduced the fraction. Sometimes you might be able to reduce in 1 step. Sometimes you might have to take a couple steps along the way. Both are perfectly fine, right? The main goal is we're reducing our fractions. Now, a question that usually pops up around this time is, do you need to reduce your fractions? Yes, always. Always put your fractions in lowest terms. Always reduce. Unless something tells you otherwise. But as a general rule of thumb, you should always reduce your fractions. Always put them into lowest terms. Anytime you're working with fractions, that should always be the last thing you do before you finish the problem, is reduce. Always reduce. Now, we talked about reducing fractions. What about some different types of numbers that deal with fractions, some different representations? We've got mixed numbers and improper fraction. Mixed numbers are numbers that have a whole number portion, and a fractional portion. Maybe 3 1/4. That's a mixed number, right? It's 3 whole parts and then a quarter. Whereas an improper fraction is a number that has a larger numerator than its denominator. So the numerator is bigger than the denominator. What happens if they're the same? You have the same number on top and bottom. Well, that's just 1, right? Anything divided by itself is 1. So improper fractions have a larger numerator than a denominator. Now, how do we convert? Let's real quick give an example of an improper fraction. Maybe 17/5. That would be an improper fraction, right? Now, how do we convert from one to another? These ideas are similar but slightly separate, but we can convert back and forth between them. You can turn mixed numbers into improper fractions and improper fractions into mixed numbers. And let's take a look at what that looks like. Let's look at turning an improper fraction to a mixed number first. Step 1 is we have to complete the division. We have to divide the numbers. Taking care to note the remainder. We always want to make sure we know what the remainder is. The whole number part is the quotient, which is the answer from the division. The new numerator is the remainder, and the denominator stays the same. So before we do an example, let's talk about going the other way, from a mixed number to an improper fraction. First, we multiply the whole number portion by the denominator. Then, we add your result to the original numerator. This is the new numerator, and the denominator stays the same. So let's take a look at some examples. Let's convert each improper fraction to a mixed number and vice versa. 59/8. So we have 59/8. So I need to complete, I'm going to do it in scratch work over here, right? I need to do 59 divided by 8. How many times does 8 go into 59? Let's think about that. Seems to be about 7, right? 7 times. And why 7? Well, because 8 times 7 is 56. And then hopefully everybody remembers that the next step in dividing is to subtract. 59 minus 56 is 3. Now, some of you might be tempted to put a decimal and a 0 and bring down. We don't want to. We want this remainder. We care about this remainder, right? It's a remainder. We're not looking for decimals. We're looking for remainders. So, I've finished the division. I have the remainder. Let's see. It says the whole number part is the answer. So, 7. The new numerator is the remainder. So, 3 becomes the new numerator. And then it says the denominator stays the same. It was 8, so it stays 8. So 59/8 is the same as 7 3/8. We can convert back and forth. What about the other way? What about going the other direction? If I have a mixed number, well, let's look. 6 and 4/7. It says to multiply the whole number portion by the denominator. So once again, we'll do some scratch work over here. The whole number portion times the denominator. 6 times 7. Well, that's 42. And then it says add your result to the original numerator. The original numerator was 4. So I add 42 to that. And I get 46, right? That's the new numerator. So 46 is the new numerator. What about the denominator? Stays the same. So 7 stays in the bottom. 46 over 7 is the same as 6 and 4/7, just like here. We can convert back and forth. Now, you might be asking, if you can go back and forth, why have two different ways of representing numbers? Well, one is for calculating. If you see a problem involving fractions, improper fractions will work more easily with the calculations, and we'll see that in a moment. If you want to understand how big a number is, a mixed number is more clear. If a recipe called for 7 3/8 cup of flour, that would make sense, right? You take 7 whole cups and then 3/8 a cup extra. If a recipe called for 59/8 cups of flour, that wouldn't make very much sense, right? That would be difficult to measure. Are you going to take your 1/8 cup and do it 59 times? Probably not. The mixed number is easier to understand. The improper fraction is easier to manipulate and do calculations with. So that's why there's two different concepts here. So we've talked about reducing fractions and different expressions of them. Let's talk about multiplying. Let's get into our first operation, multiplying fractions. Multiply the numerators to get the resulting numerator. Multiply the denominators to get the resulting denominator. If I have random fraction a over b times random fraction c over d, I do a times c in the top and b times d in the bottom. You do not need common denominators to multiply. You can just dive right in. So 3/8 times 4/9. Let's dive right in. 3 times 4 is 12, and 8 times 9 is 72. So I've multiplied. What should I do now? Check for reducing. Check if I can reduce. Turns out I can. Both 12 and 72, those both divide by 12. 12 goes into 72 because 12 divided by 12 is 1 and 72 divided by 12 is 6. So I get 1 over 6 when I multiply. How about the next one? 2 1/3 times 5 1/4. I just said whenever you see mixed numbers and you want to do calculations with them, it's easier with improper fractions. So we'll convert first. 2 1/3. Well, 2 times 3 is 6. Plus 1 is 7. 7 over 3. Remember, the denominator does not change. 2 and 3 made 6, and then 1 more was 7. We use the same technique as up here. Also, 5 times 4 is 20, and then 1 more is 21 over 4. So I've converted my numbers. Now I will multiply. I go straight across. 7 times 21 is 147 over 3 times 4 is 12. Now, I should always double check if I can reduce or not. Now, it might not be obvious whether you can reduce this, so you might want to do some trial and error. What numbers divide 12? Well, 2 does. Does 2 divide 147? No. 3 divides 12. Does it divide 147? Well, does it? Does 3 divide 147? Turns out it does. Because dividing both of these by 3, 12 divided by 3 will give me 4 in the denominator. But what about the numerator? What is 147 divided by 3? Well, if you've thought about it for a bit, hopefully you came to 49. So I get 49 over 4. Or, how many times does 4 go into 49? How many times does 4 go into 49? 12 and 1 quarter. 4 goes into 40. 4 can become 48 with a remainder of 1, right? If we did the long division, 49 divided by 4 goes in once here. 4 subtract gives me 0. I'm kind of going through this a bit quick, but 4 goes into 9 twice to give me 8 with 1 left over. So that's how I got the 12 and the 1, right? I converted to a mixed number. Either of these is fine. If a question doesn't specify what type of format to leave your answer in, you choose which one you like. If it says write a mixed number, boom. If it says write an improper fraction, boom. Make sure you're aware of what the question's asking you for, though, and you're comfortable going back and forth. How about division? Let's talk division. Now, if you can multiply, you can divide, because we're going to turn division into multiplication. And we'll do that by keeping the first fraction, flipping the second fraction so the denominator's on top and the numerator's on bottom, and changing the division sign to multiplication. A lot of people like to remember this using the acronym KFC. Keep, flip, change. Keep the first, flip the second, change the sign. So let's take a look at an example. 3/4 divided by 8/5. Well, I'm going to use KFC. I keep the first fraction. I flip the second fraction, and I change the sign to multiplication. Now I'm ready to perform the multiplication. Straight across the top is 15, and straight across the bottom is 32. 15 over 32. I should check if it reduces. Turns out it doesn't, so I will leave it like that. Now, how about the second example? I have 5/8 divided by 10. If I see a whole number in a fraction problem, the first thing you should always think is make it a fraction. By putting it over 1, you can always put a number over 1. So we will. We'll put it over top of 1, right? Now we have 5/8 divided by 10 over 1. Now I can use KFC. Keep the first, flip the second, and change the sign. Now I can multiply straight across, 5 in the top and 80 in the bottom. Now I check for reductions. Can it reduce? Well, not many options divide 5, only 1 in itself, right? Only 1 and 5. Does 5 divide 80? Yes, it does. So we'll divide out 5 from both to get 1 over 16. So we get 1 over 16 for our answer. So 5 over 8 divided by 10 is 1 over 16. Now, how about this example? We have 1 2/3 divided by 4 1/2. Well, whenever I see mixed numbers, the very first thing I want to do before I try and calculate anything with them is convert them into improper fractions. So let's do that. 1 times 3 is 3, and 2 more gives us 5/3, right? And then I'm still dividing. I'm just converting mixed numbers to impropers. 4 1/2. 4 and 2 gives me 8, and 1 more is 9. So I get 9 over 2. Now I'm ready to use KFC. Now I can keep, flip, change. Keep, flip, change. Now I'm ready to multiply. 10 in the top and 27 in the bottom. 5 times 2 is 10, 3 times 9 is 27. And that doesn't reduce, so that's my answer, right? I can't reduce that any farther. So, we saw a few different examples of division there, but notice keep, flip, change allows us to turn division into multiplication. So, let's talk about adding and subtracting. Adding and subtracting is much harder with fractions because of this first step, common denominators. We need common denominators. And then we got to convert both fractions to have the same denominator found in step 1. And then step 3 says add or subtract the numerators to keep the denominator the same. All right, so 3/7 minus 2/7. Hey, common denominator. They both got 7. I don't have to find a common denominator. I have 3/7 minus 2/7. 3 minus 2 is 1, and I keep the denominator the same. It does not change the denominator. You only subtract in the numerators. Denominator stays the same. So that's the first example. How about our second example? 2/10 plus 3/10. Well, good news for us, we already have a common denominator, 10 and 10. So I do 2 plus 3, which is 5, and I keep the 10 in the bottom. Oh, that reduces, doesn't it? What does that reduce to? Well, hopefully you found that you can take 5 out of the top and the bottom to give you 1/2. How about this next one? 4/15 plus 5/9. Do those have a common denominator? No, they do not. The way I like to find a common denominator is I take the largest denominator, 15, and I start running through its multiples. 15 times 1, 15 times 2, 15 times 3, and so on and so forth. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. And I won't need any more, because what I'm going to do now is look at the other denominator, 9. Does 9 divide any of these numbers? Have I found a number that 9 divides? And I did, right? 9 will divide 45. 45 is my common denominator. Both 15 and 9 can be made to become the number 45. How do I make a 15 a 45? Well, I multiply by 3, right? But what's the golden rule of fractions? If you do it to the bottom, you got to do it to the top, right? So if I'm multiplying by 3 there, I got to multiply by 3 in the top. In the top, I get 12/45, right? So the first fraction, I changed from 4/15 to 12/45. How about the second fraction? How do I make 9 into 45? Well, I multiply by 5. And once again, if you do it to the top, you got to do it to the bottom, and vice versa, right? You got to do it to both. That's the golden rule of fractions. So this one becomes 25/45. And now I'm ready to add, because I have 45 in both of my denominators. What's 12 plus 25? That gives me 37. So I get 37/45. That doesn't reduce. Nothing goes into both of those numbers. Feel free to double check. You should convince yourself that it doesn't reduce. Always good to make sure things don't reduce. Now, how about the fourth example? Oh, we're in that tricky mixed number territory, aren't we? Well, 3 1/2 minus 2 3/4. First thing I'm going to do is make them improper fractions. 3 1/2, 3 times 2 is 6, plus 1 is 7/2, minus 2 and 4 is 8, plus 3 is 11. So that'll be 11/4. And now I'm ready to subtract. I have fractions I can work with. I hit a snag right away. I need to get common denominators. Good news for me, do I need to change the 4? I don't, do I? Because 2 can become 4. Because I can multiply this by 2. What did I forget? To do it in the top. If you do something to the bottom, you got to do something to the top as well. Same thing, right? 7 and 2 make 14 over 4 minus 11 over 4 gives me the 4 will stay in the denominator. 14 minus 11 is 3. So I get 3/4 when I subtract those two numbers, which definitely doesn't reduce, right? 3 over 4 doesn't reduce. So I know I'm done. Notice my answer became a proper fraction. I started off with mixed numbers and got a proper fraction. That happens sometimes, right? So that's how we add and subtract. Common denominators. Only common denominators for adding and subtracting. You do not need common denominators to multiply or divide. Make sure you don't mess that up. Adding and subtracting, common denominators. Multiplying and dividing, not common denominators. Okay? And that brings us to the end of section R.1. Thank you for tuning in, and I will see you next time.